Hi, welcome to my channel, The Magic of Math. Today, my lesson is on solving equations that are in factored form. We're going to find zeros. So today we're going to use the zero product property, and we're going to factor polynomials completely in order to use the zero product property and solve a polynomial. So here's what I want you thinking about today. How do you solve a polynomial equation? So when one side of a polynomial equation is factored and the other side of the equation is equal to 0, we can use the zero product property to solve the equation. So the zero product property states that when a product is equal to 0, one or more of the factors of that product must be equal to 0. So when we solve a polynomial equation using the zero product, we're solving for, quote unquote, the zeros of the function. They also can be referred to as the roots. And when you graph the function, it would be the x-intercepts. So your roots are the points where the function crosses the x-axis. And we call these zeros because if you remember learning how to find x-intercepts from a linear function, you find those by solving for, you evaluate the function for when y is equal to 0. Well, that's the same thing that happens here. We replace y with 0, and we solve to find the value of x when y is 0. So that's where the zeros come from. And in a quadratic function or a polynomial function, they call these the roots, and they are also the x-intercepts. So previously, we've learned to find the x-intercept, like I told you, of evaluating the function when y is equal to 0. And it's the same thing we're going to do with a polynomial. And knowing how to solve a polynomial is going to help you in future units to graph a polynomial function, since you will know then the points at which the function intersects the x-axis. Kind of roots it to the coordinate plane. That's where the word root came from. So first step is, this may be different than what you've normally seen. So when you move into quadratic functions or even cubic functions, you're going to see equations or functions that y equals this trinomial. So right now what I'm showing you is I've set this trinomial equal to 0 and made it into an equation. But you can imagine that this 0 is a y, and you'll learn more about that in future lessons. So the first thing we want to do is factor our trinomial. Factored, it would be x subtract 3 multiplied by x subtract 9. It's still equal to 0 because I'm trying to find what the zeros are. So now when we use the zero product property, we're going to say this factor, remember these are factors, these are binomial factors. So x minus 3 could be equal to 0. And x minus 9 could be equal to 0, or they both could be equal to 0. So we're going to solve for x. So we add 3 to both sides and add 9 to both sides, and we get that the roots, or the zeros of the function, are 3 and 9. All right, your turn. So go ahead and follow those steps. You want to factor, use the zero product property, and solve for x. Go ahead and pause. Come back when you're ready. Welcome back. Let's see how you did. So step 1 would be to factor, and this would be factored x subtract 4 multiplied by x subtract 6. I'm going to use the zero product property, so I'm going to set the first binomial factor equal to 0 and the second. And then I'm going to solve for x. I'm going to add 4 to both sides and add 6 to both sides, giving me x equals 4 and x equals 6. And those are my roots or my x-intercept. All right, try another one. Go ahead and pause. Come back when you're ready. Welcome back. Let's see how you did. So step 1, to factor, I'm going to look for a greatest common factor. They both have a greatest common factor of 3x, giving me x plus 2. Remembering that this 3x is also one of the factors. So when I use the zero product property, I have to say 3x is equal to 0 and x plus 2 is equal to 0. Then I solve for x, divide both sides by 3, and x equals 0. Subtract 2 from both sides, and x equals negative 1. So my students often forget that this 3x is one of the factors and solving for that, and that 0 is a factor. The x-intercept or the root could be 0. So our roots here are negative 2 and 0. All right, here you go. Try another one. Come back when you're ready. Welcome back. Let's see how you did. So on this one, when I go to factor, I learn that I'm factoring a special product and it's going to be x subtract 2 multiplied by x subtract 2. So it's a binomial square. When I go to use the zero product property, the factors are the same, giving me one root. So this function may have what we call repeated roots, meaning there's only one x-intercept to this function. And again, you'll learn more about this in an upcoming unit, but that means that the quadratic function is going to have a vertex on the x-axis. Okay, and you'll learn more about that. But it is possible for a quadratic function to have one root or one x-intercept. All right, here's another one for you. Please pause, come back when you're ready. Welcome back. Let's see how you did. So I'm going to factor first. There's no greatest common factor, but I see that this is a sum and difference pattern. I identified that because 9x squared is a perfect square and 49 is a perfect square. If you want some practice identifying these special products, there's a previous video I have that will help you do that in practice. So we have 3x plus 7 multiplied by 3x subtract 7. Step 2, use the zero product property. And I'm going to say that 3x equals negative 7 and 3x equals 7. So here I subtracted 7 both sides, and here I added 7 to both sides. Now I'm going to divide both sides by 3, and I get negative 7/3 and positive 7/3. So I have, or solutions or roots to this polynomial function are negative 7/3 and positive 7/3. All right, you could also do this to a cubic function or a 4-term trinomial. So go ahead and factor and find the zeros. Come back when you're ready. Welcome back. Let's see how you did. So I'm going to factor. So we're going to factor the first two terms, and then you're going to factor the last two terms. And you can tell that when you do that, the greatest common binomial factor is going to be x plus 5, and then you would have seen that you had a sum and difference pattern. So you would have had x squared minus 4 left. So here we go. Zero product property. So I'm going to have x plus 2 equals 0, x minus 2 equals 0, and x plus 5 equals 0. And I'm going to have 3 roots. I'm going to have x equals negative 2, x equals positive 2, and x equals 5. So you'll learn more about this in Algebra 2, but when you have a cubic function, it is typical that you have 3 roots, 3 x-intercepts, because you have that S pattern to your cubic function. So that's solving equations in factored form and finding zeros or roots or solutions to a polynomial equation. They all mean the same thing. I hope you enjoyed this lesson today and that you'll subscribe to my channel and give me a thumbs up.